Now after telling you, discussing that how to evaluate the value of determinant, what is a determinant, when we can convert a square matrix in determinant, I want to discuss with you the properties of determinants. If we talk about the properties of determinants, first question, first property, the value of determinant remains unchanged. If we have calculate the value of any determinant, then the value of determinant will remain unchanged, that is will remain same if rows and columns are interchanged, or in the technical language you can say if transpose is done, then also the value of determinant will not change. Number one. Second, if any two rows or columns of a determinant are interchanged, that is if R1 and R2 are interchanged, R2 and R3 are interchanged, C1 and C3 are interchanged, C2 and C3 are interchanged, C1 and C2 are interchanged, that is if interchange is done once, then the value of determinant will remain numerically same but sign get changed. This is the second property. If any two rows or columns of a determinant are interchanged, then the sign of that value of the determinant will get changed. Third is, if any two rows or columns of a determinant are identical, we say either they are proportional or they are identical. Meaning by if R1 and R2 are same, or R2 or R3 are same, if R1 and R3 are same, or C1 or C2 are same, or you can say C1 and C3 are same, or you can say C2 and C3 are same. If any two rows or any two columns are either identical or having same ratio, same proportional, that's why in this situation value of that determinant comes out to be 0. Next property is, if each element of a row or column of a determinant is multiplied by some constant. If determinants either a row or a column is multiplied by suppose 5, then the answer of the determinant become 5 times. If it is multiplied by k, then the value of determinant will become k times of that. Fifth property, if a row or a column of any determinant is 0, suppose either complete row or a complete column is 0, then the value of determinant will be 0. Now I want to tell you what more properties of determinants are there. If I talk to you, if some or all elements of two or more columns of determinant are expressed as sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. For example, it will be clear to you, if first row is a plus x, b plus y, c plus z. It means that first row is expressible in the two terms in each of the term in first row. Second row is lmn and third is pqr. This determinant can be expressed as written here, a, then b, then c. Second row lmn as it is, third row pqr as it is. And in first row the added elements respective were x, y, z. So we have written positive plus x, y, z, and remain same second row lmn and the third row pqr. So any determinant if expressible in two or more terms, then it means that determinant can be expressed in two or more new determinants, as showed you here with the help of general example. Now I want to tell you one more property of the determinant, very important when we will solve the problems of the determinant using the property of determinants. It is if each element of any row or column of a determinant are equimultiples of corresponding elements of other row or column are added, then the value of determinant remains same, remain unchanged. And this is most frequently useful property when we will solve the problems of the determinants by using the properties of determinants.